Okay, my outstanding friends, another shocker du jour. This is Avi Loeb, and he's a professor at Harvard, astrophysicist. And he, in my opinion, is the only one with enough courage to speak out about the possibility of life in the solar system, in the universe, wherever. And he's written books about this. And Oumuamua was a big, long comet, asteroid, whatever you want to call it. And he was speaking that it possibly could have been a spaceship. I'm going to show you what I believe it is. Now, I also have things I can absolutely prove 100% because they've been tested, and there is no question about it, and which support my side of my claims that I think I have figured out why that new asteroid, whatever you want to call it, coming into our solar system, it's called 3I Atlas. And it's apparently the third interstellar or intercosmic, wherever they can. It's coming from out of our region. Let's go with that. And it's glowing green now, which is not normal. Not normal by any means. However, I think I know why that is happening, and it's got all to do with chemistry and half-lives. And I'm going to show you my evidence to support what I say, and my claim is, as I will show you right now, that there is nothing out there that is not biological. That's my claim, and I think I can prove it. Now, Professor Loeb is kind of a big shot here. He's the head of the Galileo Project, founding director of Harvard University's Black Hole Initiative, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and a former chair of the Astronomy Department at Harvard University from 2011 to 2020. Now, he's also a former member of the President's Council Advisors on Science and Technology, a former chair of the Board of Physics and Astronomy at National Academics. He's a best-selling author and so forth. So he's not a guy to be taken lightly. Okay, this was the first one I saw from Avi Loeb talking about Oumuamua, which is this, it's a finger. I'm just going to cut right to the chase. Get a biologist and an autopsy anatomist to look at it, which I have. They concur absolutely that is a finger. This right here is that right there. That bone right here, which would be behind this tendon. All these little tendons lock right through here into the bone. That's right here. That's the joint. All right, the other side of the joint is here. And it has the same thing. All the little tendons lock in. The middle of the joint is right there. And that's what lets you do this. Now, the tendons give you pulling ability to pull up and down and so forth, and they're tough. That's the white part. This right here, this part that looks scaled off, is what is called grip skin. It's friction skin. It's the tough skin that's on your fingers. And it peels off completely separate from what's underneath, which is the flesh. This right here, that little circle, with these little things running out of it, is the apical tuft. And that anchors the tendon up here at the tip. So we've seen the finger come right down to the joint. It continues down, and it's snapped off right at the knuckle. Right at the knuckle. That's the knuckle. You see that black spot? You see that white spot? Those are the blood. One or the other is a vein or an artery. These two spots right down here are the actual over-the-top tendon. and that goes over the top so you can pull it this way, and the other muscles and tendon let you go that way. Very sophisticated device, but it is a finger. And all he's got to do is show somebody in the biology department, an anatomist, and have them look at this and just explain, yes, here it is, that's a finger. And that is grip skin. All right, my claim is everything is biological. This is a meteorite. It's an iron meteorite, what they call that. It has all these different metals in it, and it still has blood in it, vein and artery blood. The red is the artery. And I have meteorites here, several of them, and they are also biological. And I can give good evidence to support that everything else is biological, just like they came back with the sample from Bennu. We'll look at that right now. Right, this was quite a sophisticated mission. They went, this is all funded by the government, of course. They went up to this asteroid Bennu, went right inside and pushed everything out of the way with nitrogen gases, and went down and grabbed a chunk of it, came back to Earth with it. It's here on Earth. Let me show you. Okay, these are pictures from the mission in total. They went up, and they just landed right there, and they shot a blast of nitrogen gas just to dust it off, and they went much deeper than they had thought, and they grabbed a hold and they pulled up whatever they took back with it. Now remember the colors, the red, the yellow, and the black, and you see how separated the black is from everything else. The black is just one of those things that I'm going to tell you right now, this is a heart, and they brought back chunks of a heart. They landed on that heart and grabbed chunks of it, just like this, which is heart sarcomeres from a heart attack victim here on Earth. They came back with the exact same thing. Phosphate layers, totally unexpected, which were the membranes that hold the sarcomeres. And here's their samples right here, somewhere. Here they are right here. Those are the sarcomeres. They went in and they grabbed a chunk. They came back to Earth. It's here on Earth right now. They know it has all the signatures. It's got the DNA, the RNA, the uracil, every single biological characteristic you can have. It has, and it has the membranes and the phosphate, which is the phospholipid membranes. These are the sarcomeres, and it's here on Earth, and it is identical to heart muscle, which is also here on Earth in people's bodies. This is a little bit different, it's a little bigger. The heart's bigger. And that heart is virtually the same as Psyche. This is Psyche right here. A little easier to see because there's not so much dust on it. This thing's huge. I'm going to go do a whole video on this, explain it. But remember the red, the black, and the yellow, that's the blood. These are the valves. You see them? This is what a heart is right here. When the hearts break, they break right along that seam. And they all do it, basically. And when they pop off, the plumbing just goes away. Wherever that went, I have no idea. But what's left is this. And even the autopsy guys tell me, yes, we see it just separates right off. And it does, because there's a red and a blue line that circle this, which is the artery and the vein. And they oppose each other, but while they're moving, everything's fine. When you die, you get iron banding, and it pops it right off. That's why I said before, look how the black stays away. So look how this black is. You see, that's like somebody put paint on there. The black hates the red. And it hates the yellow too. Black wants to be on its own, and it just wants to be black and crusty. It's nasty, crusty black stuff. That's all I could tell you. And they create actual borders and push. So when your heart is like this, and iron banding pops it right off. So that solves that situation. Now, what does Bennu look like? Well, it looks basically identical to this. And this is Psyche. This is much bigger, and they have a mission going out there right now. This is actual pictures. Here's your red, your black, and your yellow. That right there is the tendon. The plumbing's gone. You got your valves. different colors down here because one of them's a vein, one of them's artery, basically. You got tubes coming out of them. It's not an artery. I mean, that's not an impact. That's a tube. There's another one down at the bottom down here. There's another tube. All of these other little blowout spots are actually blown out. Those aren't necessarily impacts. There might be some, but for the most part, those are what squirted out of there when they boiled out. You see how these boiled out little tubes. The heart is nothing but blood, and blood is almost nothing but metal. That's why they're headed there, because it's just so saturated with metals. You see, this is it right here. Between that red and the blue, they snap. It turns black when it stops moving. It turns black. The red stays red. It never changes. And it stays fluid, and I mean fluid. We have found rocks with blood literally running out of them. I'm serious. All right, I showed you this, the heart. And they snap right there. Now, Phil, a friend of mine, found a heart complete. And he saw red blood running right out of this crack. And he whacked it with a hammer, and it just snapped right open. And here it is right here. That's red, wet blood. He could see this on the rock on the side of it. And it had stuff on the top. The plumbing and so forth had banged around and eroded a little bit. But you can see this is the muscle surrounds the heart. And he saw that red, and he whacked it right there, I believe, right that spot. And out came this. And you have your yellow, you have your black, and you have your red. Those are the chambers of the heart. They separate out the blood and pump them this way and pull them that way. And here's what the top was that was on top of that was this. That was on top of those buckets of blood. And there's where the solid red one was. There was a yellow and there's a black. So the two things together, I mean, that is about as fresh as you can get. And that's, I know when these things had happened, I believe. There was a point in time when there was a great, terrible flood, and all the ancient cultures had that, and they said that the oceans boiled. And that is the process that creates the mud fossils and the salacious ooze that came up from the basement floor of the ocean. Still there now, because it sinks back down. It's 2.5 times heavier than water. But that's why at this one particular time, they don't know why, but I do. It's because the earth wrenched, and all that stuff came up. And it surrounded, the whole earth was supersaturated silicon. Silicon fills in voids. If they call them veins of quartz, well, that's it, silicon dioxide. It fills in voids. And primarily, arteries ran out and left areas where they could be filled in with quartz. Now, I'm asking Professor Loeb to look into this Bennu debacle here. This thing's been here for 2 years. You can actually see the rope muscle that's in the muscle that they took back from Bennu. There's ropes of muscle that go like this. If you cut them, and then you look at them, what's the pieces that make them up, these are the pieces they're called sarcomeres. And here they are right here. And there's a layer of phosphates, phospholipid layer, in between each layer of these ropes. And then you have the sarcomeres inside. This is not unknown. This is very well unknown. Anybody at Harvard should obviously be able to find somebody there that understands what sarcomeres are, and understands muscle, and understands if there's blood inside of an iron meteorite, something happened there. And every one of them has it. I have one here, I think I showed you. I want to put it in a microscope anyway shortly. And here it is right here. It's a little iron meteorite, but it's a little one. It's still got enough iron in it. Now, what we're talking about today is Avi Loeb talking about that new 3-eye atlas is giving off a green vapor with no iron. Now, that's not possible in a biological universe, except for, I think I have figured out why it's happening. I say if that thing is given off what they think is dust, it's not dust. It's boiling off and cooking, just like this right here. You see this? I reported to the European Space Agency exactly what my feeling was here, that this was a hip joint, and it is boiling off barbecue gases from an artery, and these are from the tendons. This is Comet 67P. They went up, European Space Agency, landed the Philae lander, took samples, Kenneth and Juliet they called them, did the chemistry on them, and it's biological. They knew it was biological, and you can see it. This shot doesn't show it in a true biology, but where do you see this? It's a hip joint. It's a hip joint. You see that? The other ones was shooting from behind, so you couldn't see the hip piece. This one here broke like right here. But that's what it is. It looks like it's from a hip to me. But these are all in space. Who the heck knows what's going on out there? But these things are absolutely stunningly enormous, and they are what they are, just as this is a heart. And again, get somebody up there at Harvard that has some biological capacity to understand what they're looking at. They understand the different oxygenation states of blood and why these different colors come up. And that's why we're going to be talking about the other one that's showing green because of nickel, they say. Let's look into that because, well, let's just look into it. But you have to understand there's oxygenation states, and that's what causes these different colors. Even though it's still iron, it has a different oxygenation state. All right, 2 and 3 primarily, and we're going to look into this. It's going to get a little complicated. We have to understand dipole electron flood theory and the way you have decay. All right. Because this involves decay, but it doesn't involve decay downwards. It's going to involve decay upwards. You say, how can something decay upwards? Well, it takes on more particles. It's changing. Let's call it changing. All right, there's decay going downwards, and there's upcay going upwards. Because you can, well, I'll show you. And we have had that happen in the... well, hold on one second. I'll show you right now. In, where are you? There. The Grand Canyon was hit by a fiery comet. And every culture on Earth had the same story. And at the same time. And it scraped all this out. This didn't drain out of here. There's nowhere for it to go. If you look at the whole thing, it's a gouge, and it pushed all this stuff down into Mexico. I looked at this carefully. This is a gouge. And again, this was a creature's body here, and it ripped it down into the guts. And if you look at the stuff that's all over that area there, it's basically intestines and all that stuff. I'm just telling you, this is just a fact. And the thing in space here, this... well, you saw a Mao. You saw a 67P. This thing's enormous. That thing's absolutely enormous. That's not even enormous when you consider the other one I showed you here. This is Psyche, and that's a heart. There's nobody can dismiss this. It cannot be dismissed. They're going there right now. They're headed there. And because there's going to be so much metals, they're going to love they say if they smelted this, they'd have billions of tons. You know how big this is? That's 177 miles and 144 miles that way. Miles, 170. Can you imagine? Can you imagine? And that came out of some creature's body. That is a heart. I don't care what anybody says. You can tell me, oh, that's crazy, that's crazy. Well, I didn't say it wasn't crazy. It's true. It's crazy, but it's true. And they're saying when it smelts, it'll look like this. Now, smelting is the key we're going to be talking about 3I Atlas. Because I believe there's a possibility that some of the stuff cooked off and at the same time possibly bumped up decay, not down, and forced the iron up into the nickel range. And I'll show you how that happens from isotopes. But this is, that's a heart. I don't care what it is, it's a heart. It's case closed. And it has all the same chemistry, it has the same color signatures, it has the same biology, it's everything. And they brought some back from Bennu, which is also a heart. Here's a Bennu. Wait, hold on, where is it? This is right here. These are valves right here. These are valves right here. And they went and grabbed it. Now this is smaller than a mile, so this is not huge. But that's the stuff they brought back, and here it is right here, the sarcomeres. So, as far as I'm concerned, I have evidence to prove everything I have been saying so far. And if they get an anatomist, an autopsy guy from Harvard or anywhere, I don't care where they are, as long as they know what they're doing, it's just undeniable. That's where the bone is, right there. And all the little, there'd be a flat plate of tendon here. And these were it splays right out at the very end. See it? Let me bring that in a little closer, you can see. That is nothing more than this. All right, there's a flat plate of tendon, and it goes right in here. All those little shoots go in there, and they anchor into this area in the back here. So that anchor's tight. Tendons are in forever. They don't go bad. Tendons are tough. So get your anatomist and take a look at it. Now let's just keep going here. I want you to look at this carefully. You see that's shooting out there, and this is shooting out here and here and there and there out of these spots. It's not just blowing off. And they confirmed that the dust is unevenly distributed. So it's not just like dusting off. It's blowing out of certain spots when it gets hit by the sunlight. You see how that's glowing? All these little spots are glowing. That's why they're shooting out, because there's moisture in there. And that moisture, as I will show you, I believe is biological. All right, pay close attention to this. This is the glow.
With a bright head, as if the comet is spreading a broad fan of material to one side. Hubble confirmed that the dust is unevenly distributed. There's a wide plume of dust pointing toward the sun and
a wide plume of dust pointing toward the sun.
Much weaker tail stretching in the opposite direction.
Okay, pointing towards the sun, and I can tell you exactly why that is. Let's make sure we understood what he just said. All right, you've got a hazy, elongated glow.
Head. As if the comet is spreading a broad fan of material to one side. Hubble confirmed that the dust is unevenly distributed. There's a wide plume of dust pointing toward the sun and a much weaker tail stretching in the opposite direction.
All right, the one pointing towards the sun, I'll show you exactly why that's happening. Okay, they were talking about the coma shooting towards the sun. Here it is right here on Comet 67P. Now, the sunlight is coming directly here, and this is shooting out the gas vapors directly towards the sun, exactly as the 3IA is doing right now. So the sun has to be hitting down in this, I'm going to tell you right now, it's an artery, and I will show you that. Now, going up the side here, all these little shoots, these are shooting out from where there's little blood vessels up here and where there is little tendon entasis down here. And I will show you that. But the only way they shoot out of there is they have to have the fluids, So you need an artery or a vein or something that has a lot of fluid in it, or these which have what I call slurpy, small leucine-rich protein, wet stuff that lets your tendons slide back and forth. And that's why they're coming out exactly where the sun's hitting them. And they all do the same thing. And they'll only do it when it gets close enough to the sun to cook it. This is 10 years ago. And I reported all this to NASA and all of them. I said, this is a body part. Let me show you the rest of it. It's undeniable. Here, let's just stay with this. Remember I showed you that blast coming out of here. I'm going to show you where it's coming out from, which is this artery. That's the artery that's coming out. 40 meters is this much. I figure this to be about 500 feet across. All these little balls in here are little blood vessels that enter in to service the tissue. And that's somewhere down, I'm not sure, it's somewhere down in here. But anyway, this is, I believe it's a hip joint. And it fractured here. And it got ripped out of the socket right there. And here's what it looks like in a Z human body. Right here. It just got ripped out of here and broken right here. Sometimes they break here, sometimes they break here, it depends. But this is what they're showing it came from. And it could be that, it could be something else. I don't even know if it's human. I don't know. There was battles in the heavens. And these things are not unusual. They're big, but they're not like, as far as I'm determined, I can tell you, there's no question in my mind at this point, if you can show me something that is not biological that came through space, I would love to see it, because this is biological. And look at the size of it. This is Raleigh, North Carolina. This thing is huge, and a lot of them are. I believe I showed you Psyche. If not, you'll definitely see it. And I showed you Bennu, which we have a sample here on Earth. And Bennu is a good size heart. It's a heart in space. These are the valves. And it's covered with debris. Now, Psyche doesn't have all that debris on it. You can see it flawlessly. And these are the valves. And I showed you the iron banding, which pops them off. I showed you the tubes that are coming out of in the different colors. I showed you where they landed on there, and I think I've shown you everything that you need to see. But the one thing about this new asteroid is the vapor shooting out of it, and it's shooting out like this towards the sun, because the sun is cooking it. Once it gets over here, it's not going to cook it anymore. So anyway, and they're all different. It's not dust blowing dust off of here, which is what they always had said, and I think they still believe that. I'm not sure what they believe anymore. But here's another comet. All right, this is from the Kuiper Belt. This, my friends, is a ligament. And you say, well, what do you mean by that? You take a bone like this, which is a bone. It's a mudfossil bone. And I believe it's probably a wrist bone, something like that. And you have two bones that are anchored together. I mean, they're anchored. They cannot come apart. This is a ball in a socket. And then where the other one goes, that's in that socket. That's a ligament. There's one here and one here. And they glue these two bones together so they don't come apart. Now, I don't remember how big that is or anything else about it, but that's a body part. Now, there's another one here somewhere. Look at this one. This is Comet Hartley. Same thing here. You see them blowing off? Where the sun is hitting it, it's gassing towards the sun. I mean, it just happens because there's little blood vessels or tendons or whatever. Now, this looks like, I'm not sure what, like a little chicken leg or something. I don't. There's some gooey stuff. This is what I look at. This smooth stuff here, I would say more than likely is tendon. That tends to get pretty smooth. This is fleshy-ish stuff. and there's some blood here. There's something wet here. There's wet stuff here, and I believe it's blood. And the same thing was boiling off of here too. And they all do the same thing. They all boil off the same way. And 67P is the most obvious. What else? Here's another one up here. This was from the Rosetta mission. Oh, I guess this, if it was Osiris team. Anyway, Rosetta was, no, the Philae mission. Rosetta's just something, no, hold on. No, okay, it was Comet 67P, and it was the Rosetta Philae mission. The Rosetta was the name of the mission, the Philae was the lander. And now this is 1 year after, and there's the Rosetta mission reveals comet onion-like layers, gases, molecular oxygen, water transport. I would like to look into that. Here we go. This is a year after touchdown.
It's been an extraordinary year for the Rosetta mission. Since landing on Comet 67P Churyumov-Gerasimenko, the combination of continual data from the orbiter plus several days' data from the Philae lander has provided a comprehensive picture of a remnant from our solar system billions of years old. Recent images of the comet have revealed unusual terraces or strata, rather like the layers of an onion, as well as pits containing walls up to 400 meters high. These layers help scientists determine that the comet was formed by a collision between two comets, resulting in its distinctive rubber duck shape. The comet has no magnetic field, but Rosetta has identified a number of gases from the nucleus, including water vapor, carbon dioxide, hydrogen sulfide, and even argon, the first time it's been detected on a comet. These gases were traced by Rosetta's Rosina instrument, and its laboratory is based here at the University of Bern in Switzerland. The latest discovery is familiar on Earth, but not on a comet.
The biggest surprise so far is certainly molecular oxygen, because that was not expected at all. And this tells us a lot about where this material comes from, where it was formed. It correlates very well with water, and I think, I'm not sure, but I think it shows you that the water was formed in the molecular cloud and not in our solar system. It was already existing when it entered the solar system.
The water coming from the comet was also shown to have a different isotopic ratio to that on Earth. The unusual shape of the comet, with one lobe much larger than the other, means that as it spins through space, parts of the comet are often in and out of shadow. The Virtus instrument has revealed how water has been transported from within the comet to its surface via sublimation, where water changes from ice to a gas without going through a liquid phase.
All right, I showed you what that actually is, and that is from an artery.
We measure the abundance of ice and the temperature in different points, getting closer to the shadows. And you see an anti-correlation. When you have the maximum abundance of ice, you have the minimum temperature. As soon as the temperature increases, the ice diminishes, because it's sublimating away.
These images show the changes on the surface from red, with no water ice, to blue, where ice has appeared, all within several hours. The European Rosetta mission covers many facilities across numerous countries. At ESA's European Space Astronomy Centre in Madrid, you can find Rosetta mission manager Patrick Martin.
The mission extension will last until end of September next year, and the idea is to spiral down the orbiter Rosetta towards the comet slowly, diminishing its altitude, and then settle the spacecraft on the surface, hoping to be able to control it as long as possible.
When Rosetta descends towards the comet, it will enjoy an equally close-up view to its Philae lander 1 year ago. By then, the mission will have used 21 different instruments to study a comet at all stages of its activity, from approaching the Sun to being at its closest distance or perihelion, to moving away from the Sun back towards the cold outer reaches of our solar system. It will provide insight into our planet's own formation by giving us the most detailed knowledge yet of a comet.
You could see the details. Stunning. Alright, so my claim is we have biological evidence right here in the asteroid Bennu. It's here. They know what it is. I can't believe they don't understand it. And it has all of the signatures of life. Right there, the sarcomeres, the membranes, the bundles. It came from a heart. So, and the chemistry's there. Everything is there. And this is just the same stuff you have here on a heart on Earth. Now, I don't see how anybody can deny the things that I'm showing and say that they make no sense. I've been working with a guy who has a Newtonian telescope with some really special little doodads going on that I don't understand. But I can tell you what, the stuff he's taken, some of the shots are just stunning. And everything does show up as a dipole. Everything is a dipole. Dipole electron flood theory is virtually 100% now. Look at this, is black pushing the white. This is exactly as it comes through the Venturi. And black and white are coming together through this particular Venturi. And this out here is a Whistler wave preceding the white. This is almost identical to a nuclear explosion where pow, and all the white goes out in a circle from the center, and the black pushes it out, and the white goes in nuclear bombs, it burns and doesn't move anything. It has no weight, and then the black comes and hits and knocks it over. But preceding this is the Whistler waves. You see this distance of them? And there's no real substance to them. They're just like really blurry, nothing. Then you come back to here and you see really tight, strong waves. This is called a Whistler wave. If you was out here and a nuclear bomb went off, you'd see the bomb go off here and you'd hear brrr, and that would be these as they passed you. But then you'd have to wait for the blast to come, and then a little while later, this is as deep as you get, this stuff, and I'm showing it, and I'd like to have somebody respond to it. And what we did was we took the dipole electrons. Hold on one second. All right, we took the dipole electrons, two of them back to back make a photon. One of them, just a black and a white, all that is heat. It's not electricity, it's heat. The white all by itself is electricity. A pair of these, which they call a gluon, is a dipole electron. And that, my friends, is the same as this. It's identical to this. And the only reason you can see the black is because the white or whatever color is behind it, and you can't see it because it's blocking it. That's the only way you can see the black. It doesn't emit, absorb, or reflect. The white gets big, gets small, has no mass. This has exactly the same mass. Never changes, can't get big, can't get small, just a hard, solid mass. And they see these at Fermilab, CERN, and so forth, but we can see them from light. They use huge particles, smash them to bits. We started with the little ones, so I got to be honest with you, way ahead by doing it this way. And we accelerated the light, and we can see the light accelerating using CMOS, which now CERN is using. And we accelerated the light. And then we split the light right here. The black split away from the white. That's fission. On this side, they came back together. That's fusion. The black, as you can see, sits on top of the white, and that's the only way you can see it. There's plenty of black in here, but you can just barely see them. They're starting to show up. And then when they get right on top of the white, you can see them in their standard ball form. Those are the muons, and they're normally connected to the electron neutrinos. The electron neutrino goes into the showers, white, brilliant showers. The muon just keeps going on by itself as a black ball. Exactly what I'm showing you. And this is from Fermilab. This is not from me. This is from my stuff. And this is the acceleration of the light. And right here, it creates fission, and here it's fusion. And light spins in a circle. It actually looks something similar to this. It spins like this. It doesn't flap in a wave. And it's made out of two dipoles. And everything I'm talking about here is dipole flood theory. Dipole electron flood theory. And this is what a proton looks like, or a neutron, whatever you want, an atom even. I believe that all the dark matter goes to the center and all the white matter surrounds it and crushes it in. And the Russians did see this in space, not understanding, I don't think, what they did see. This is it right here. I can explain this experiment at some point in the future here, but it was the charged particles in a vacuum chamber. There's a lot of things they didn't consider, and I will illuminate those, so to speak. And they said when they saw this, they freaked out. During the experiment, they contacted the Earth guys who couldn't believe it either. One guy locked himself in his room for 3 weeks at max Planck. They just couldn't figure out what the hell is this all about, how that happened. And they never did figure it out. That's 10 years ago. That's 10 years ago. Now, we did the light experiments. We did the green and the red at the same time. And we can tumble the red. That's the only way you can make it tumble. Otherwise, it always spins according to the plane of the Earth. It never goes this way or that way. Except we pushed it with the green to make the red tumble. And they are all photons. They all look the same. Just like this, whether it's green or blue, red, doesn't matter. They all look the same. And they all have the same black component. The only thing that changes is the color of the speed. Let's say, put it that way. The speed determines the color. And the same way here. As you go up, it goes up from red into the green and then into the blue. And I have shown that. Well, I can show you the red and the green. The blue's pretty fast, a little too fast to look at. But the green is very fast. It recombusts out here because it just pushed the red out of the way. The red doesn't have a lot of energy compared to the green. And then the blue has way more energy than the green. So the blue is just kind of too fast to look at. You see, here's the green with those same particles. Same particles. See, there's no difference whatsoever. The green is identical to both of the other ones. Only the blue you really can't even see. Here's the red. I just showed you the green. Here's the red. I mean, they're just identical because they're photons. And the ones in the center here are charging up because they're just about to hit dead on the Venturi. So the backsplash makes them display as photons. These are what they would call Majorna neutrinos. They're not fully formed yet, but they do apply this way, straight like this, and straight like this, and that's what this will be. They're never going to be twisted like this. The only time you're ever going to see that is when we forced one to push the other, which I showed you a minute ago. The blue is too fast. You can't see much anything. You see it coming in. And then you can see that there is two particles there. That's about the best you're going to get of anything with the blue. Through glass, it was interesting because it creates a very interesting pattern. But anyway, the blue, we didn't do much with. This is what I told you, how we made the red barrel roll by pushing it out of the way because of the green. It just slapped it. You get out of the way, and they just go. So those are field-to-field interactions. Here's the particle spinning. I told you, it's a spinner. It's not a flapper. All right, it comes down like this. Some go that way. Some go off this way. Some go this way. But whatever it does, it matters. Once it gets through the other side of the Venturi, they create their own exact pattern lines. Because they're repulsive. You see how perfectly separated they are? I know you see them in a ball here. I got to be honest with you, I don't understand the ball nature, but I'm not sure. But I can tell you what, nobody can deny that. And I can see them coming into the Venturi in these kind of shapes, which nobody's ever seen before either. Now this cut right across here, that's just the tip of a drill bit. They spin. All right, and again, I showed you this. This is Cherenkov radiation. Muon neutrinos, electron neutrinos. The black ball, the white turns into the showers, and the black just goes on its way. Now, you see how they're coming back in here? You can see they're all exactly the same size. They're exactly identically the same size. But you can't tell that because some of them are tighter, balled around, and some of them are looser. But there's black all over here. There's black everywhere. There's black in here. You just don't see it. It doesn't emit, doesn't absorb, doesn't reflect, but it will obstruct. This is black matter seen due to obstruction. Otherwise, you're never going to see it. It's here. It's all over the place here. You can't see it. And this is what they're looking to do, is to create the muon electron showers, which we did. And we can put a harvester right there, I would think, and have maybe even free energy. Who knows? All right. I showed you the hip. And here's what a hip looks like. These little flares here are where the tendons are, and that's where those little gases were shooting out. Somewhere in here there's an artery, and that's where the gases were shooting out. It might even be the one that feeds the muscle right here. It probably is. Wherever that was shooting out from, that is where blood was being supplied. The rest is quite obvious. And then there's a bundle up in here, or over here. I guess it's up in here. It might be over there. I don't know. But there's a few little tendon interfaces in here, and then that bundle of muscle comes and attaches right at the bump in the bottom here. Now, let's go back and look at it in space. Don't forget, this is where gases are shooting out. Something's feeding blood up to that muscle. There's going to be a bunch of blood coming out of there. And space smells like steak. Look it up. All right. Take your time and look at this ball. You see this little bundle here? You see that? That's muscle, I believe. It could be tendon, but I think it's muscle. These little pinchy things, I think, are little muscle cords. And these, though, I know, are tendon. These little straight, flat sheets here. Those are tendons, and in between each tendon, there's synovial fluids, and they have to slide back and forth to be able to twist and move and do all those things. And that's where that little bit of fluid was coming out, the little spritzes were going. And on the top, where the muscle is, or where something else attaches, I could see some other stuff shooting off in different ways. This, I believe, is nothing more than blood that has just dried and run off. It's bodily fluids that are dusty, but they're not just dusting off when it goes there. So you're not seeing any display of gases or anything right now, because it's either not close enough to be gassing, or it's just not hitting anything that has enough fluid in it to gas off. But when it does gas off, this puppy gases. Now, this is February 2015. This was January 31st, 2015. So this particular window apparently was when it was doing a lot of gassing. And you can see how they're shooting out to the side. These are shooting straight up. Something shooting straight to the side here. They shoot according to where the blood vessel was pointing, and that artery is going like there. And the only way they do it is when the sun hits it directly, and you can see some serious direct sunlight. Okay, I suppose I'm going to leave it at this, but I would love to talk to Avi Loeb, and I think I do understand the chemistry of how the green in the nickel is showing up. And I think it's because you see iron's here, nickel's right here. They both have oxidation states of 2 and 3. Iron can move up. It doesn't have to move down. Decay doesn't mean you have to go down. You can decay upwards if you're being impacted or forced with particles to force into that iron. And that may be. We don't know where this came from. It might have come through something here where it just collided with something, or something happened to it that forced extra particles into it, pushing the iron up to nickel. And we had this happen in the Grand Canyon, where we have our uranium deposits. The Grand Canyon got hit by a fiery comet. It was all recorded. It was about 1500 BC. Velikovsky had the whole thing. Everybody in the world had the same documentation. But I believe this is where it hit. And the Grand Canyon is not just water ran out of there and all pushed everything out. No, it's gouged. And it's literally gouged out, and all that stuff was thrown down into Mexico. You're looking on the Google Earth, it's no question. And it's all biological underneath there. There is nothing but biology. And even Jesus Christ said, he who finds the earth or finds the world will discover a carcass. And that's exactly right, no question about that. And there is right there. These are in the Nag Hammadi texts, discovered after they were hidden for 2,000 years, because they would have been destroyed. Nobody's known about this until 1945, when they came to light. And this is a huge library, a big 52 different texts and a lot of very, very deep stuff. Jesus said, and this was for 114 sayings, it was written down by his scribe while he was walking around here on earth. He said, you record these things I tell you. And he said, Jesus said, whoever has come to know the world has discovered a carcass. And whoever has discovered a carcass of that person, the world is not worthy. Now, if you have come to discover the world as I have, well, then you will be above the rest of the world, meaning the people of the world. Now, and this is something people say to me. They say, well, when he said this, he meant who know the world has discovered a carcass. Well, that's the people. Their minds are literally dead. I mean, I'm serious. I'm sorry. It's just a fact. So I don't care whether it's the world in its bodily, structural rocks and stuff is literally a carcass. And yes, that's true. And whoever has discovered a carcass of the person is not worth. My point being is we are living on gigantic dead creatures. And it's the beginning of the Bible, it said there were giants inside the earth in those days. And after that, there was more giants on the outside of the earth. That's what they were in the world in those days. This stuff is true. And we need to get our head around this. And Jesus said, search, and well, let's see exactly what he did say. Oh yeah. And you got to you got to start to interpret these things, and you will not taste death. And interpretation doesn't necessarily mean you have to solve every issue here. You got to make it an interpretation of them. In other words, you're searching. Jesus said, those who seek should not stop seeking until they find. When they find, they will be disturbed. When they are disturbed, they will marvel and will reign over all. And after they have reigned, they will rest. Wow. These are some of the things, like, I'm disturbed and I marvel. I don't know about reigning and all that business. I don't want to reign. I just want to rest. Yes, I could go for that. Okay, I don't see any reason to go any further, but that's why it's shooting towards the sun, which makes it seem unusual. Well, it's not unusual, that's just the way it is. And all this was energy forced into this, and these are now uranium mines. Uranium is an unstable element. It's way up here. It's just too many particles. There's too many particles packed into it. It's radio decay. It's trying to get back down to what its nature was, which might have been heavy metals. But when you force extra particles in, like a gigantic fiery comet smashing into the Earth, well, you're going to decay upwards. I'm going to show you this just for a geek factor. Hold on. All right, you don't have to understand this. It's very simple, though. This is isotopes of nickel. Isotope means this. If this is nickel and it's stable, now let's come down to, these are all isotopes. This is all nickel, but they're all different size nickels, but still nickel. And it's going to get to a point stable, 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 and stable. These sizes right here, all right, 28 and 32, 28 and 33, 28 and 34, 28 and 35. These are protons, these are neutrons. And they just get bigger and bigger. So you're down here, you're at nickel 60, which means 28 and 32. So that's nickel 60. You add one more of these, and you go up to nickel 61. That's 28 and 33. And that's still stable. It doesn't want to give any up or take any on. And then you go up to the next one, 62. And then my point is, all you're doing is adding one more or taking one less away. Well, what would happen to iron if you smashed it like crazy with a ton of extra particles? It would go up. You see how nickel can decay down to iron, Fe? Fe, 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 Fe. It can decay down to Fe. Well, that means Fe can decay up. And I'll show you that. All right, see, these are iron. And every one of these is a different iron. Just means it has one more or one less of these. Now, these are the stable. And then you go up from there by adding extra balls, and the next one up would be cobalt. All of these jump from iron up to cobalt. All right, so you can decay upwards. That's my point. We're not decaying downwards. We're going from iron up to cobalt, which is the daughter decay. The daughter isotope is up. Now, what about cobalt? Cobalt is going to send you right up into the nickel. So with enough of a hit, you would force the iron into cobalt, and the cobalt would immediately go right into the nickel and up beyond that. There's probably some very exotic metals in that thing if it hits something really hard, and it must have. Now, the thing that bothers me about this 3I Atlas is they say there's no iron, and I find that hard to believe. But if that's the case, all I can think of was the iron got pushed into cobalt, and the cobalt got pushed into nickel. That's the way that the thing works in biology with enzymes. But enzymes break bonds to make things like that happen. It's called nucleosynthesis. Nucleus is being synthesized into something else. Well, this is a little different. This is forcing particles into something else. You hit that hard enough, and a few of these are going to go into there, and it's going to become nickel. All right, and if you get hit the whole thing hard enough at one time, bang to bang, which I don't know if this happened or not, or maybe it went into a black hole and just smacked into so many particles that it had to absorb some, and it somehow popped back out. They don't know what they're talking about, black hole. They don't even know what a black hole is. They don't know what dark matter is. So we can't rely on anything that they're talking about, black holes and so forth. All right, and I showed you what's in space, and I showed you what's here on Earth, and there's giant hearts here on Earth. There's a guy standing there, his heart. That's heart muscle. These are the valves. That's a lung, heart and lung machine. I showed you the tendon enthesis. Well, that's a ligament, and that's what they are right here. Between bones, you go the ligaments. So you got a ball on one end and a ball on the other end. One's big, one's small. And they hold them together, the ligaments. Tendons are different. Tendons come down to a big muscle, and the muscle has to do a lot of that. The tendon just has to do a little bit, enough to give it flexibility. And it's an anchor. The human body is fascinating. When you study it as much as I've been studying it, you just, look at this. This is what a tendon's made of. You see these little blocks? Those little tiny blocks? And then over here you see these little tiny fibers, and then you see the different colors. You see it? Those are collagen. And each one of these is a different type of collagen. There's like 28 or something like that. And one gets tough and strong, and the other flexible, the other one's stiff. And they put them in bundles to make a tendon, and it has all of these capabilities. And they break right across. They're flat as a pancake. That's why you see them all over the place. When you see these hex fibers all over the place, and they're flat as a pancake off the top, that's because they were biology that was built like that. Okay, wrapping it up, my friends. I just showed you these tendons and how they are little straps and how they have blocks. Well, here they are when they're weathered off. And they're huge, they're enormous. Giant's Causeway is nothing more than tendons. I'm sorry, that's just a fact. And they break right off like those little blocks. And the bundles are good size, and they get smaller, and then there's thousands, zillions of these inside of each one of these, and there's a zillion of these inside of that, and then there's a zillion of these inside of this, and same thing here and here and here and here, and then you get down to the end of the little fibers. Those are the ones that invest into the bones, and into wherever they lock it in. And at the very end, there's going to be a tiny little ball. There's going to be a tiny little ball holding it into that bone so that it can't come out. So, I think I talked before. I'd like to talk to Avi Loeb or whoever is in charge of some of this stuff. I've tried to make advances towards all of the people here. And, they don't respond, so I don't know what else to do. If you have any way you can help to get this seen, we're spending a lot of money. We should take into account what we're seeing. And I'm showing research that this is every bit as good as anybody's got anywhere. As far as I'm concerned, if you think it's not, if you think I'm just being an idiot and showing silly things, well, tell me and let's talk about it. But when they go out to Psyche here, which is a heart, and they will go in there because they say when it's smelted, it'll be nothing but beautiful metals, and they'll be able to make all kinds of things. It's a heart. And the reason it has the metals is because hearts are saturated with metals. So, I guess I'll leave it at that. Thank you. Have a sterling day. I love you all. Bye.